Now we want to take our right triangle and start moving them into standard position, going around this circle. The setup is I've got a circle with its center at the origin. And one of the places I want to be able to identify is where half the radius is. Notice I've got a circle with a radius, and I've marked off horizontally and vertically halfway, a radius of half what we have. So circle, centered at the origin. Circle, center the origin, and we can identify where half the radius is. So that's where these marks are. I want to be able to find half the radius going all the way around. When we have an angle in standard position, we say the reference angle is measured from the terminal side to the nearest part of the x-axis. A reference angle goes from the terminal side to the nearest x-axis. Reference angles are measured from the terminal side to the nearest x-axis. The nearest x-axis is either the positive part of the x-axis or the negative side of the x-axis. But if I have an angle theta in the second quadrant, the reference angle is going to go down towards the negative x-axis. So here is our reference angle. I'm going to put a subscript of r to indicate that theta r is a reference angle. So make a subscript r to indicate a reference angle. If I have an angle in the third quadrant, the reference angle goes from the terminal side to the nearest x-axis, which is once again the negative x-axis. So from the third quadrant, we're going to go back to the negative x-axis. So in our third quadrant, our reference angle will be in here. In the fourth quadrant, our reference angle will go towards the positive x-axis. So if our theta goes all the way around to the fourth quadrant, the reference angle will go up to the positive x-axis. So here is our reference angle. In the first quadrant, the reference angle will just be the angle. So we have angles in standard position, and we want to be able to identify where the reference angle is. The reference angle goes from the terminal side to the nearest part of the x-axis. So the reference angle will always be an acute angle. Any questions? Okay. We're just naming parts, right? We're just identifying parts. This is the part where we've opened the box from IKEA And the first page has a little picture of all the parts that are in the box. It says you got 3 of these and 4 of these, and we're just making sure we've identified all those parts. Now I want to go into the circle and identify some reference angles that we are going to care about. Or pretend to care about. So first, a 45-degree reference angle. Split it in half. I'm not going to be able to leave that there. First reference angle that we're going to care about is a 45-degree reference angle. There are 4 quadrants, so we care about a 45-degree reference angle in each of the 4 quadrants. Let's draw that. So 45 degrees in the second quadrant. There is a 45-degree reference angle. There's one in the third quadrant. And there's one in the fourth quadrant. I'll start with 45, even though it's the one in the middle, but I start with the one in the middle because it's the one in the middle, and it's easiest to locate. Here are the other reference angles that we care about. We care about 30 degrees and 60 degrees. To find the 30-degree angle, go halfway up vertically, and then cut over to the circle. There's a 30-degree reference angle. It goes halfway up vertically. Second quadrant, halfway up vertically. Down below, we've also got halfway. So go halfway down vertically. On both sides. And then we have 30-degree reference angles going all the way around our circle. .30 degrees from the terminal side to the nearest part of the x-axis. Next, I'm going to do the same thing with the halfway points vertically or horizontally.
So if I go halfway through the circle horizontally and draw a vertical line. How big is that reference angle? Everybody know? I might have said it earlier, but I don't remember. 60. This one is 60 degrees. And then do the same thing over here in quadrants 2 and 3. These are angles that we were going to want to be familiar with. 0, 90, 180, and 270. And also 30, 45, and 60 degree reference angles in quadrants 1, 2, 3, and 4. So what we want to identify is what are all these thetas?
What is a 30-degree reference angle in quadrant 1, 2, 3, and 4? What's a 45-degree reference angle in quadrants 1, 2, 3, and 4? What's a 60-degree reference angle in quadrants 1, 2, 3, and 4?
I'll do the tricky quadrant. Quadrant 1, theta, the reference angle is just the angle itself. So a 30-degree reference angle in quadrant 1 is a 30-degree angle. Your job is going to fill out the other 9 boxes. Figure out what 30 degrees is in quadrants 1, 2, 3, and 4. Figure out 45 in quadrants 1, 2, 3, and 4. Figure out 60 degrees in quadrants 1, 2, 3, and 4. 9 angles to find. And then remember. All you have to do is figure out what they are and then remember them forever. No problem. I'm not saying you have to memorize them. You just have to remember them. Does everybody know the difference? Memorizing sucks. Remembering just takes time. All right, let's pause the video here. I want you to figure out these 9 angles so that we're all on the same page. And so next week, when the first thing I ask is what are these angles, we'll remember what they are. So let's pause the video while you take a few minutes and figure out these 9 angles, 9 remaining angles. The way we're going to say this is we're going to say a 30-degree reference angle in quadrant 2. So I'm going to say something like 30 degrees in quadrant 2. What angle has a 30-degree reference angle in quadrant 2? How big is that angle? 100 what? Not quite. 120 is going to be our 60-degree reference angle because going all the way around is 180. So if we just go 120 degrees, we've got 60 more degrees to go to get to 180. So 120 is a 60-degree reference angle in quadrant 2. So what's a 30-degree reference angle in quadrant 2? Now, 60 degrees is over here in quadrant 1. We're looking for something between 90 and 180. I want this angle where there's 30 degrees left to get to 180. 150. Now we match. So in quadrant 2, I'm looking for an angle between 90 and 180 that has a 30-degree reference angle. So if I start off here at 0 and go 150 degrees, I've got 30 more to get to the x-axis, the negative x-axis, which is the one in the middle. What's a 45-degree reference angle in quadrant 2? 135. Keeping with this 45-degree reference angle, because I have the green pen in my hand, what is 45 degrees reference angle in quadrant 3? So something between 180 and 270, that's 45 degrees away from the negative x-axis. 225. What about 45 degrees in quadrant 4? So I've got 45 degrees from the terminal side to the positive x-axis. What's left over? 315, because if we go 315 around to this 45-degree reference angle, there are 45 degrees left to get to 360. So let's go to the 60s. It's 60 degrees in quadrant 1, it's just 60 degrees. If I put 60 degrees above the negative x-axis in quadrant 2, we'll be at 120. What's 60 degrees in quadrant 3? If I start off here at 180 and go 60 more degrees, where are we going to end up? 240. And what is 60 degrees in the 4th quadrant? 300, because there's 360 all the way around, and there's 60 from the terminal side to 360, so 300. Finally, what is 30 degrees in quadrant 3? Here's 180. 30 more degrees. 240 is going to take us all the way down to the 60-degree reference angle. 210. So 180 plus 30 is 210. And finally, in quadrant 4, there's 30 degrees to get to 360. So where are we at? 330. So going around the circle, we have 0. The ones we want to know are 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 215, sorry, 225, 240, 270, 300, 315, 330, and 360. What you want to do is recognize all these values. And you don't want to recognize them in this format because it's not going around the circle. Your next job is to draw a fresh circle, and instead of just labeling the reference angles, label these angles going around the circle. The idea is to draw a new circle, correctly place your 45, 30, and 60 in all 4 quadrants, and identify what those angles are. Also, the 30s are always red, the 45s are always green, and the 60s are always blue. That's not standard, that's just what I always do. Any questions? You don't have to memorize these numbers. You don't have to memorize these values, but you do have to remember them. This is like a trigonometry times table. I have to be able to say something like 210, and you recognize that that's a 30-degree reference angle in quadrant 3. I have to be able to say 45-degree reference angle in quadrant 2, and you think of 135. Just like when I say 7 times 8, you say 50 something. It's just stuff that you have to know. You don't have to memorize it. You just have to know it. Any questions? Comments? It's not, everybody looks so happy like this. You're like, well, isn't there a more fun way we could do this? It's like, oh, maybe. But I don't know what it is because I'm not fun. You can tell that I'm not fun because I'm a fucking math teacher, for Christ's sakes. Any questions? Comments? It's not a remark. Like I said, I need to break this down into like 1 minute TikToks. That's a great way of disseminating information. If you want people to think they know stuff, it's perfect. It's perfect. It's like 1 minute blast of information. And like, oh, wow, I know stuff. Like 2 days later, you don't know, right? But as long as I keep a steady stream of 1 minute chunks of information that I don't expect you to remember later on, it'd be perfect. And you get like one of the important things, which is like confidence in your ability to do stuff. Any questions? Let's start TikTok. Chop all these up into like 1 minute bits. Already on YouTube, and I clearly don't know how to YouTube. I don't know because I just paused like, oh, today we're doing like in this video, like finding derivatives. It's like, oh, that's not a clickbaity title. 8 simple tricks to crush your algebra test. I mean, that's like a clickbaity title. That's like how you can title math videos. Your teacher doesn't want you to know this. The people that are making those videos are a lot of times like literally math teachers, and they do want you to know this. So they're starting off right with a lie. It's like, oh, that's fucked up, guys. That is messed up. Your math teacher doesn't want you to know this. I saw one of those videos, like, oh, wait a second. I watched some of that person's other videos. I'm like, oh, dude, you are a math teacher. What the hell? My favorite is when you do something like this, because this is, you start off with something like this, and this looks like it's going to be a pain in the butt to remember. And so this is like when questions come up, it's like, oh, why do I have to know this? Has anybody ever thought that? I want you to know that when that question comes up, that is your brain's way of saying, I don't want to do this. Make that asshole justify why I have to do this. But then I have a problem because I'm not allowed to like look into the future and see what you're going to be doing and tailor make the class. I go, all right, I've got this great trick. It's one simple trick to figure out what needs to be in the math class. What I do is I look into the future and see what the student is doing, and then just teach them the stuff that they're going to need to know. And I'm like, oh, Leach, you can't be telling the students what you see that their future is. I go, come on, man. It's so simple. All I have to do is read their mind. And they're like, oh, whoa, 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 whoa. You're not allowed to read students' minds. And then I hold up the rules. I'm like, oh, where does it say I'm not allowed to read their minds? And they're like, oh, just don't do it. So I'm not allowed to read your minds or look into your futures and like tell you what you're going to be doing. It'd be so much easier if I could just read your mind. You know what I mean? It'd actually be extra easy if I'm like, oh, why don't I just implant the knowledge that I want them to have in their minds? Like, whoa, whoa, whoa. That's incredibly invasive. You can't just like implant knowledge, matrix style, into their head. Like, well, why do we have to do this the hard way? You know what I do is I travel through time and I look ahead. I'm actually not reading. I can't read minds, is what I'm supposed to say. But what I do is travel into the future, look you up and see what you're up to, and then come back and make sure that you know the stuff that you need to know. Then if there's something that you need to know, what I do is I travel back into the past and then fix it back then so that you know it in the future. I know you don't believe that I can travel backwards through time, but I can't. Watch. I'll be right back. Hey, I'm back. Whoa, everything's different. Holy shit. I should not have bought that latte. I know you don't see it as being different, but holy shit, everything is so different. Wow. Weird. Hang on a second, I'll be right back. Okay, that's different, but this is more acceptable. I can't bring anybody with me, so I'm the only one that can see all the difference. The rest of you, when I went back in time and changed all the shit, if this progress normally. I can, however, bring all of you with me forward in time. You want to go into the future? Right. Yeah, very good. Welcome
to 5 seconds into the future. I can bring you into the future, but we can only go forward at the normal rate.
Here's what I want you to know. I want this circle. I want you to picture this circle with 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, 360. I want those all the way around. Quadrant 1, quadrant 2, quadrant 3, quadrant 4, 30, 45, 60, and on the quadrant, the 90. Don't go so far into the 90s that you show up with like Janko jeans. That would just be too far. Too far. But know your angles. All right, that's gonna do it for today. That's your task. You have 1 week to learn this circle going all the way around. We're only gonna add to it, so get this part down. That's it for this week. I will see you next week. Everybody have a nice 3-day weekend. And thanks for playing.